Hello friends, I'm Avinash. Today we are going to extend our last discussion where we created the VM instance for Unix, Linux. So today we will try a few things, including creating a new instance for Linux. We'll install the Apache and try out few things and understanding um, how the commands looks like on Linux. We're not going to extensively discuss Linux here or commands here. We just want to understand a few basic things because the focus is more on GCP and just creating instance. But going forward, if I will be exchanging more on Linux or Windows side based on what we based on the scope of the discussion I like to put in front for that particular video. Today, the more focus on just creating a simple instance for Linux, installing Apache server, and understanding basic. So let's start with creating an instance. I will not go through the project. We have already a demo project which we have used in our previous videos. Let's go ahead and create a VM instance. Same compute engine, VM instance, and click it. And same again, create instance. So we'll name it test Linux 2 this time, although we can still use the test Linux 1 as we have deleted the machine already. Label, just name Avinash Linux or something in machine, save it. Again, we're going to use the US South Carolina, any zone, doesn't matter. Still going for the general purpose. Today we are going to discuss these three types, compute optimized, memory optimized. But before that, we like to cover how to create the VM instance, and because these will be more theoretical, and the scope, the type basically is based on the, the scope or the architecture you have in your mind to create the machine. But definitely we'll come back to this and then we'll cover them in a little bit more detail, not extensively. So again, like there are several machines available, but we're still going for the E2. And let's create a little bit more powerful machine, like a standard 16 gigabyte machine or CPU. For this demo, it doesn't matter like which machine I use. At the end of the day, everything is attached, like based on our usage, we create the machine. Like if we powerful machine, then we select all kind different configuration. But just for the demo, we could have chosen the small configuration. But just to try, I'm just selecting 4 CPU, 16 gigabyte memory, and then we need Ubuntu, and this is the one we will go for 2004. The one below are the minimal, so you don't get all the packages along with that. If you need more packages, then you may have to install it separately. It all depends, like when we configure the production server, we go with the minimal, and then we choose our package accordingly. The performance high, and we only keep the things which we need to run our application or to do a specific task. And the one at the top, they're like more vanilla images with like all required package will be by default installed. So it's slightly more than what is available from the minimum. As we discussed, we're just doing the demo and trying few little things. So we just go with the 2004 LTS, select and allow default access. We just keep it default service account, allow HTTPS, and click create. So in few seconds, our machine will be created, and we're going to try simple things. As you can watch in the notification center, like the wheel is stopped on the notification center, and the machine is created successfully. If you want to see the details, click on the details. SSH is already enabled. We discussed how to add the SSH if it's not by default added to our firewall. So you just have to add the firewalls and add the port, TCP port in the HTTP area, and that will enable the SSH for that particular machine. Okay, so our machine is ready. So let's click on the SSH and see if we can log in. So there are a few commands we're going to run. So as you can see, we have successfully logged onto the machine with the default service account. And as you can see, this showing I logged in as AVI12776. That's my login ID. And test-Linux. Sorry, the typo mistake. Linux -2 is my machine name. And as you can see, the dollar in the last, which it's represented as a user login rather a root login, and the tilde sign just after the colon, which represent like it's a default home directory. It's very simple to read. The first bit before @ sign is the username. After @ and between the colon is the machine name. And after colon, there is a tilde sign which says it's a home directory, default home directory. And the dollar sign represent to the user login rather a root login. Let's see what happens when we change it to the root. So we type in command sudo -i. So what does it mean? Sudo - is a super user do interactive. So can you see the magic here? Now we are logged in as a super user do interactive. the user change to the root before at the rate sign, you can see it. And then next is the machine name, and then the tilde sign is the default home directory, and the hash represent the root, the login. So which is very easy to understand. Like this way you can easily recognize like where we are. Like for example, if I say make directory here, make directory test. So we have now test directory. If I go cd test, can you see now after the tilde slash test? So for default home directory slash test. And then if I go further, you know, in this make directory test again. Now in the test, there is a test directory, and I go further again, test directory. Now you can see default home directory slash test slash test. This is my directory. So it's very easy to understand. So let's go to root directory. And we are in now the root directory of we go home directory now from here, so slash home directory. There is a event to. So these are the small, you know, list of commands I wanted to show in this session. Now what we will do, we will just try to run the apt update. So this is going to update all the packages of Ubuntu on this machine, and I'll have the latest patches installed. So this is all done. And now what we do is we install Apache. As we discussed earlier that we will install the Apache server and Apache 2. So later when we run this installation, it prompts for yes or no to if you want to like just run the installation without system prompting you for response. You can provide your response here -y, or you can type in y later. I prefer like just complete in one go, or otherwise I can just run it like this. And then now can you see like it is prompting for y, and I can just carry on. So now the Apache is installed and all the modules are configured and running. So we can check. And the www my HTML page is cat HTML HTML and cat index.html. Okay, so the same thing, we use the public IP and try to browse the page. And you can see the Ubuntu home page. Simple exercise we will try. Now we will edit this page and see if we can or create a new page. It's up to yourself. We just want to see how we so we can just say here insert updated page for demo and full stop and same WQ to save it and then come back to refresh, come back to page. Put the text too big, but as you can see it's on the top. It's probably we can put the text here. Updated page for demo. Updated page. So this one is pretty simple. So today we tried a few things and we told the Apache. So this is what I wanted to cover today in terms of like installing Linux and understanding basic commands, how to identify which directory we are without having to look like a list and then try to find out where we are. I think the command prompt itself tell us a lot, where it can tell us the user, machine name, and which directory we are by just looking at it. So now, friends, let's come out of this and try to understand few things which we were discussing, like what kind of machine we have to select when we are creating a new VM instance. It prompt you with a lot of other options, and we were always selecting the default one. So the first thing we will do here, we're going to go and delete this machine. I'm pretty sure, like by the end of everything, will be master and create, delete the machine for sure, along with the learning a lot of other things. But that's quite important. If I leave the machine, then it's, no, it's all chargeable and it's going to cost us money. Now we just have to wait for machine to get deleted and then try to extend this session by just a few more points related to creating VM instance. The create VM instances topic is still not finished, but what I'm trying to do here is just adding on whatever I'm learning and doing my research, so that I'm just trying to add those things sequentially to create VM. So what will it will do in theory, like it will start building up the knowledge, like when we do the architecture and we have to create a machine for the project, we are clear with our question, the uh, owner, like what kind of machine, what they really want to do with that machine, whether they want to run a reporting tool, whether they want to run an application with a 1 million user or 10 million hits a day, and it's a memory intensive, it's a CPU intensive. So based on those queries, we select the initial configuration. So this is the idea behind all those options. So let's see what are the options available. Whenever we create the machine, we have extensively discussed the name, labels, regions. Now, this is where we will focus today in this session. There are four types here: general purpose, computer optimized, and memory optimized, and GPU. So the general purpose machines are more for like if we like to set up use a computer or a small application running just a web server or something like a small database or anything like which is which you can calculate is far enough for the available configuration, because even for the general purpose there is extensive settings available. Comes with a custom where you can select your own how many CPUs and memory you want, or they are pre-configured one. So there are a small configure where you can go up to 2 CPU, 2 GB one, and then there is a standard configuration where you can go up to like 32 CPU, 128 gigabyte memory. So 8 is 32, 16 is 64, and it's always like a 4 times. If you see, like every CPU will have a 4 GB memory, and in the small, every CPU will have 1 GB memory or a 2 GB. But standard we can set, we can kind of put the relation, but don't trust this. But right, so far it matches the number, so we can say it's all 4 times. In the high memory, we have RAM is higher compared to CPU. So whenever any application using a lot of memory compared to CPU, like a file, which needs a lot of memory on the fly, a file system where a lot of people accessing the file system, then you need more memory compared to CPU. Because the file processing may not need that much, but it will definitely memory, like a 10 megabyte file. If you think about like 10 people, 20 people doing that, all of a sudden you need like almost 400 megabyte if the file size increases, and why, along with the processing power required for the machine. And then the high CPU, where like the databases, which requires a lot of CPU to run the database along with the memory, where the CPU processing power is more required to execute things than rather keeping things in the memory. So yeah, based on your requirement, you can select the configuration. So that's what available in the general configuration. So they are the best price and the mid performance sort of range. Similar to like when we go and buy our laptop, if you want a gaming laptop, then really high configuration, all those things. The same applies here. What we want to do, that's the question we ask, and how much cost, affordability, risk. There is a lot of things comes into the picture when we design the architecture. It's not like because sometimes the price also plays a role, and then how much risk we can take along with that. It's all impact analysis and everything is there, but We understand like what the general purpose machines are, like they're the best price and the mid performance machine. And rest of the configuration based on what we want to do on those machines. So compute optimized is only one configuration, a standard one where you need more computing power, compute intensive workload where we have um, right now the one example I can think of is if I'm running sort of like a lot of um, artificial intelligence where it is computing a lot of different factors or doing a risk analysis uh, where a lot of things happening on the compute side rather on the memory side. So I will go for this kind of machine, compute optimized, which will provide me better performance where everything is happening on the server side. And using a lot of CPU to calculate different factors. So there's only one option here is like forward by Intel Cascade Lake CPU platform. Depending on your provider, it will there may be different settings. But for GCP, I think those are the only options available, but in future it may change. But we just have to understand why and when we have to use different settings. And there is a memory optimized. It's again like all only Intel processor. And you can see like it goes up to 96 CPU, 4 TV CPU, 8 TV CPU, and 3.575 terabyte memory. And so they are really for big tasks like SAP, data warehousing, SQL analysis servers, big data, those kind of areas with the memory optimized machine. And the GPU, it comes with a high graphic card, so definitely it tells where it's mostly used for gaming. Gaming need a lot of graphics memory to run your images smoothly. That's where the GPU machines are used. So, friends, this is all about the machine configuration. If I have to add something later, I will come up with a new video. But I hope it will help you understanding like where and what kind of machine we will require for a certain type of task which machine is required to do. And then we can select the machine accordingly. But that's all for today, my friends. Hope you liked my session. Thank you. And I'll come up with another session soon. Thank you. Bye.